Welcome pre-calculus students. Right now we're going to take a look at polynomial functions and their zeros, how to find them, what their possibility are. We're going to get a couple different rules to kind of get you going as to how to start a problem saying find the zeros of a polynomial function that's a really high order or high degree. Given p is a polynomial function with integer coefficients, the rational zeros of p, if they exist, there may not be any rational zeros, so if they exist, they must be in the form of p divided by q, where p is a factor of the constant term and q is a factor of the leading coefficient. For example, if we take something like, I don't know, 7x squared plus 11x plus 21. If we have any rational factors, we need to start by finding out what is the, here's our constant term, this will be our p value, q, this is our leading coefficient. They're going to be, we're going to list all the factors of 21. 1, 3, 7, 21. Not only those, but there's also, these are all positives and negatives, because you can take two numbers divided by, negative 3 times negative 7, both those would be factors of 21. We're going to divide them all by the two factors of 7, plus or minus 1, plus or minus 7, to look at all of our combinations. So this would leave us with positive or negative 1 over 1, positive or negative 1 over 7, positive or negative 3 over 1, positive or negative 3 over 7, positive or negative 7 over 7, positive or negative 7 over 1, positive or negative 21 over 1, positive or negative 21 over 7. A lot of these already simplify and you kind of don't need to worry about them. So for example, 1 over 1, 7 over 7, that just gives you plus or minus 1. 1/7 we would need to take. 7 we would need to take. 21 divided by 7 and 3 divided by 1 are going to be the same thing, so we just need to write plus or minus 3. But we would need to include the 3/7 as well, and plus or minus 21 over 1, which is 21. So what that means is that if we have rational zeros of this, if they exist, they're either going to be 1, 1/7, 7, 3, 3/7, or 21. This narrows down the things you need to check when you're going to try to use synthetic division to figure out all the factors later. For any polynomial p with real coefficients, if the sum of all the coefficients of 0, then 1 is a root and x minus 1 is a factor. As I change the sign of all the terms with odd degree, if the sum is still 0, then negative 1 is a root and x plus 1 is a factor. For example, if we had something like, I don't know, 2x squared minus 3x plus 1, when we add up all the coefficients, you get 2, negative 3, that gives you negative 1 plus 1 equals 0, which means that positive 1 is a root and x minus 1 is a factor. Again, this is a nice little test we can put in there to say, hey, it kind of gets us going. It gives us a starting place. It's a quick, easy way to figure out what we're looking for. The other, what this is talking about is if we change all the things with an odd degree. So if we take something like, what's a good function? So for example, if we take a look at something like 2x squared plus 7x plus 5, we're going to change the sign on all the odd degrees, and that's in this case x to the first. We're going to make this 2x squared minus 7x plus 5. When we add these coefficients together, 2, negative 7, positive 5, that implies that negative 1 is a root and x plus 1 is a factor. Let's take a look at a couple examples. It says list all the possible rational zeros of the polynomial 3x to the fourth minus 2x squared plus 3x plus 42. Again, these are in the form of our constant over our leading coefficient. And it's not just the numbers themselves. These are the factors of the constants and the factors of the leading coefficient. So factors of the constant, we got to break down 42. You can always do prime factorization if it helps. That's 6 times 7, 2 times 3 times 7. So the factors of the constant are positive or negative 1, positive or negative 2, positive or negative 3. Let me pull this out of the way. Positive and negative 6. Oh, excuse me. Positive or negative 7. Positive or negative, let's see, we've already used this 3, so that would be 14. Positive or negative 21. Positive or negative 42. All these are going to be divided by the factors of 3, which are positive, negative 1, positive or negative 3. When you start combining these, you can say 1 over 1, that's plus or minus 1, 2 over 1, plus or minus 2, 3 over 1, plus or minus 3, 6 over 1, positive, negative 6, similarly 7, 14, 21, and 42 are all possibles. Then we can go back with a 3 to get positive or negative 1/3, positive or negative 2/3. 3 over 3 is just going to give us 1. We've already got that taken care of. 6 over 3 gives us 2. That's taken care of. 7/3 hasn't been, nor has 14/3. 21 over 3 gives us 7. We've already got that. And 42 over 3 gives us 14, and that's already taken care of. So these are the list of all of the possible rational zeros of the polynomial g of x. Again, the reason that this helps us is it kind of narrows down our search. It doesn't look like it narrows it down, but it really will help us narrow down our search when we're looking for things to factor. Okay, next, find all the possible zeros of f of x. At this point, you've probably seen some questions where they give you 1 or 2 of them, but now, and they say find the rest of them. But now you're just saying, here, start off, try to figure it out. The first test I always do is check for x equals 1 or x equals negative 1. So when I add up my coefficients, I see 1 plus negative 3 is negative 2. Negative 2 plus 4 is 2. 2 minus 2 is 0. This tells me that x minus 1 is a factor. So when I know that x minus 1 is a factor, I'm going to do synthetic division with positive 1. 1, negative 3, 4, negative 2. Bring down the 1, get 1. Add negative 2, negative 2. Negative 2 plus 4 gives me 2. Multiply together 2. Add together gives you 0, which gives you a function x squared minus 2x plus 2. Okay, after we divide by x minus 1 to get to the quadratic x squared minus 2x plus 2, we're left with a problem that we know how to solve. Sometimes if we start with the degree greater than 4 or greater than 3, we may have to go through the process again. And we can use the use this idea of finding out all the possible rational zeros to help us give us place to start to check our work. But in this case, we're left with a quadratic. I'm going to use completing the square to solve this. X squared minus 2x plus 2 equals 0 to find my zeros. X squared minus 2x equals negative 2. Divide this by 2, square it to add to the other side. Get x squared minus 2x plus 1 equals negative 2 plus 1 is negative 1. This is x minus 1 squared equals negative 1. Square root both sides to get x minus 1 equals positive or negative I. Add 1 to say x equals 1 plus or minus I, which gives me my 3 zeros are x equals 1, and that was found adding up all the coefficients, and then x equals 1 plus or minus I.